Everybody, I'm Roberto Polli, I'm a solution architect at Partech. I love writing free software and I got a couple of Red Hat certification. I'm very happy to be here today in a way or in another. That's a concrete sign that PyCon Italia is more than a conference, it's community, it's friendship. Before the beginning, I'd like to thank the proud sponsor of this talk, Partech. Partech provides expertise in IT infrastructure and services and business intelligence solutions and applications for the financial market. Today, we will speak about talks and how to use talks to describe a Python project. So, describe projects with code. Continuous integration is the practice of merging developer working copies several times a day. The goal of this practice is to avoid weekly merges, which are time-consuming, and to have, as soon as possible, all the changes merged on the development branch. All these merge works requires runnable project descriptions and a high degree of isolation because every developer should be able to run and test his work separately and eventually in parallel. It is very important so that every step is reproducible and deterministic. We should test automatically that the merge works because this merge happens many times a day. Together with continuous integration, we have continuous delivery. Having the opportunity to merge continuously every branch, every patch to our software, we can implement a pipeline that brings this software that is thoroughly tested with isolated build from stage to production in an easy way, in a speedy way, because I don't have to take care of big chunk of changes, but only a small path made of close pebbles. Though it has solid ground in the Java enterprise world, with tools like Jenkins, the Archean integration test framework, and so on, even in Python we can do continuous integration. There are tools like Travis continuous integration, that is a platform as a service for doing this kind of practice that supports Python. There are plugins for Jenkins, though Jenkins is written in Java. And there are tools like BuildBot and Talks that helps in building a isolated software that can be tested with tools like NoseTest or PyTest. What is a project description? We need to describe carefully our project so that we can test it continuously. We need to describe every step. The Java world has an established standard, the POM, the Project Object Model, implemented by Maven, that is a build software. The POM not only describes but implements too the whole software development life cycle. It starts with the ability to build libraries and application, take care of dependency downloads, conflicts resolution, unit testing, including the Java version, for example, 1.6 or 1.7 compatibility checking. Then it takes care of packaging the software and install it locally to be ready for integration test. There are phases which takes care of documentation, deployment on an application server or a stage release, or even release on remote repositories, that is, distributing software. All these phases are defined in a huge, actually is a huge XML file that specifies which are the remote repositories we should deploy to, which are the remote repositories we download dependencies to. We can even specify a list of mirrors and proxies, so we can use layered repositories for download. For example, if we need to download a library from our internal repository, then we specify that all the libraries matching some patterns should be downloaded from our internal repository, and all the other libraries should be downloaded from other. For specific packages, there are even vendor dependent repositories. Well, okay, for you, the people that maybe already know Maven sucks. Yeah, though hated for the extremely complex description of the XML that is quite error prone, the slow build system, Maven surely achieves the goal. Maven enforces a standard workflow. It is the one tool to build, test, and deliver, and it has plugins for almost everything. Here you can see all the Maven phases of software building. There is a validate phase, there is a generate sources, process resources, and then compile. Then it process classes, generate test, compile and run unit test. Just test is unit test. If the unit tests are successful, then a package is built. Then here we can intercept and add hooks on all those phases. For example, we can trigger some kind of delivery in the pre-integration test phase so that we can execute integration test on a remote application server, for example, and then after the verify, that is, the integration tests are run smoothly and with a correct teardown, there is the install. The install usually is an install on a remote repository for libraries, or it can be, for example, a stage environment. The Python world is more fragmented. We have a wide variety of tools that change in time. Without considering Python 3 migration, we've got distributable packages like libraries or projects on PyPy. They need to use the setup.py file to store project metadata information. The package installation happens via PIP, but pip doesn't provide conflict resolution. Pip reads dependencies from requirements.txt, that is a preferred choice for Python applications, and from the install requires variable of setup.py. Then we have setup tools to build and distribute software, but there were many projects that were used for this to achieve this goal in time, and still there are projects that are using these utils only too. So when we run into some of these projects, we should take care of passing further parameters to pip. Packages archives then. Packages archives are distributed via egg files. This is an old, without metadata format, or with wheel, that is a new archive, that is a zip compressed archive. But then we will have even zip distributions and source archives. Wheel is a very nice format because it can support even binary or platform dependent archives, but as of now it still doesn't work very nice on Windows with Windows binaries. So a Java developer approaching Python asks, where is my POM.xml? Well, there is another issue. Reproducibility requires isolation. While Java application with Maven packs all its dependencies together with the application, Python has a centralized archive for libraries. So if we just print the sys.path variable, we can see that many Python packages are in the user directory of the operating system. This is a great problem for isolation. Java, in fact, doesn't have system libraries, but everything is included into a version-specific installation directory. All the other libraries that aren't included in the standard library, in the Java standard library, are just installed and deployed inside the application package. So to implement a continuous integration chain, to use a continuous integration strategy with Python, the first step is to separate builds from system Python. virtualenv is a tool that helps us to do this. When we run virtualenv, we specify a system Python version and it creates into a specific directory that we can see here. A whole set of all this Python distribution with the interpreter, with Python executable, and with setup tools, pip, wheel, and everything we need to implement a Python isolated environment. The important thing we should remember is that when we create virtualenv, the binaries, the setup tools, distribution, pip, well, and so on, is taken from the system library. So we should remember to always upgrade pip and setup tools and wheel to the latest distribution, or to upgrade those packages inside our virtualenv before playing with it, if we need a new virtualenv with the latest PIP wheel and so on. So having many binary Python distribution on our operating system and having the virtualenv package on our operating system, we can create many copies, many virtual environments of various Python versions, and all these environments will be separated because after the binaries are copied, those are separate directory and completely separate environments. Then, what is Tox? Tox is simply a virtualenv manager. It can create separate Python virtualenvs, install dependencies via pip inside those virtualenvs. It can even run setup.py to install and build our custom project into those virtualenvs, and then it can execute specific commands. This is the simplest case to execute pytest or nose test, so that we create the virtualenv, install the dependencies and the package, and run test. This is the basic scenario. The Tox configuration file is tox.ini. We can use it to describe our projects because we should use it to run the tests or our environment. The next thing on toxini is that we can use it to give Java developers an entry point to our application. It's not as complete as a POM XML. We still need to read external file like setup.py, footer requirements. Maybe we should even run some scripts, but it is a good starting point for Python newcomers. So, Tox configuration file is named tox.ini. The first trick that I'm going to tell you is start this file with an how-to. Our Java friends don't surely know Tox. So in this way, using the pound sign, you can mark the comment. You are just telling them, hey, it's really easy. Look at how to use it. This is a kickstart. They will be able to build all the software, download, install dependencies, build the package, run test with one command, tox. If they are curious or you have to troubleshoot any phases, you can use the -v parameter. And to show all the supported Python version of your project, just use tox-l list. The first step, actually this is the first step you'll usually take if you don't read the tox ini, or if there are particularly complex tox ini file. Just list the environment. We can actually just run the tests not on every environment we find, but only on one of them. We can specify the environment name with the -e flag. This command line just run tox on the Python 2.7 environment. Easy. And this is our first real tox file with two stanzas. The first one, the tox, describes the runs. So it's the environment list is just on Python 2.7, and there is a parameter named skip source distribution. The default is false. So if you're using a web application and, for example, your project is a Flask web application and you don't have to install packages anywhere because everything is self-contained, just put skip as dist equals true. The testtemp stanza defines the global settings and the basic workflow of the project. We're just setting the Python path of our virtualenv, adding the local folders so that we don't have to install anything, just use the local Python path. Then it's Flask application, so we have just two dependencies, nose for testing and Flask. In this case, reading here, we know that there are only two dependency packages. Finally, how to run the test. Just nose test, and you see here a poseargs string between braces. This posearg string is replaced with all the parameters specified after the tox double dash parameter. As we saw before, here, tox take parameters. So if we want to separate those parameters of tox from parameters of tox executed commands, we just have to specify them after the double dash. We can set even the work dir of tox, that is where we are going to create virtualenvs. Here we are creating virtualenvs in the my project dir, okay, under TMP. Because on Linux TMP is usually mounted in RAM, so it's quite faster. Okay, this can be useful if we have a lot of I/O during the processing of the virtualenv. We can even specify our requirements outside tox. In this case, we have extended the previous tox and we moved the application requirements in the requirements.txt. By default, tox runs pip. So in this case, it just runs pip nose and all the requirement package. In case we need host-dependent executables, well, tox will complain if we are using executables outside the virtualenv. So if we want to use them, we must whitelist them. In this case, as we didn't want to install make and gcc under the virtualenv, we just whitelist them and rely partially on the operating system. This is fine if we are confident that these won't make our build less isolated or reproducible. What about positional arguments? We can even use or specify a default value here. So it's mostly a bash syntax, but it's fine. We can set the default args. So if we want to tox with specific tests, we can do it using the double dash. But if we want just to run all the test suite, we just have to specify tox and wait for everything to finish. Let's see talks in action now. Here we have a simple directory with sources, tests, requirement file. Let's see how this simple talks animate. Okay, in this case I just put a brief comment, just run with talks on check all the list all in the environment. Okay, quite similar as the other we have seen before. Then, okay, this is the environment. Okay, we want to know what Tux is doing, and now we want just run a specific test file. Okay, this is this file with the Tux version, and then all the rest, the pip freeze, all the installed packages, and then the run of nose with all those three tests. We can even pass further parameters and force the recreation of the environment. We set the environment recreation before the double dash, and the -v, the verbose for nose test, after the double dash. Now we're going to introduce wheels. Wheel is a new Python standard packaging format. It's essentially a zip file with metadata and binaries and Python file inside. It's based on PAP 427. It requires setup tools newer than 0.8, and let's see how does it work. When we run pip downloads Python package from the index. Thanks to wheel, if we use wheel, we can download wheels for our architecture from the index. Otherwise, if no wheel is found, pip will download package source distribution, will build it. Then it will populate the wheel cache, and finally will install the package from the wheel cache. During this phase, packages are labeled, for example with the architecture or the specific Python version they use. Now packages can be retrieved from cache, and in this case this means that when we recreate continuously our virtual environments with talks, packages are just downloaded now, copied from the wheel cache, and there is no need to continuously build the package from the index. So download and build package from the index. So how to use wheels in our talks ini? Well, this is important because it can allow us to save time and CPU cycles and so preserve the environment. If we have to to install pandas, it will going to take a lot of time, at least for the first time, because he's going to build pandas or all these dependencies, which includes NumPy. We can override the default pip command and use cached packages. Well, by default, Tox uses pip install, but in this case, we can just run install command and override it with pip install -- use wheel. The package brace expansion resolves to all the packages specified in the dependency, which includes those are specified here, but even those specified with the requirements txt file. So pip will package and create those will package into your system default wheelhouse it is named. As this directory can be different between various machines, it could be useful here to specify with -f or -- find link the directory of the wheels. Then again run the test command. The first run will take a lot of time. Further run will go straight on and fast. Here we have our Toxini file with LXML, that is a compiled package, and the override of the default install command. Remember, Tox use just pip install for installing all those packages. Then we specify here the directory where to find wheels. -f is the find link option of pip, and then -- use wheel. Commands is just the standard NOS command to run a single test. Okay, now we run Tox and we ask him to recreate the package, the virtual environment without wheels. This will take a lot of time. Instead, I just run it and boom, finished. LXML is already compiled, is in the wheel cache, and I can, well, again, recreate. Again, another one. This is really nice, and it's the same if you use huge libraries like pandas or NumPy. Enjoy it, use wheels. Okay, we have our wonderful Python 2.7 project, and we have to switch at least. We have to start the switch to Python 3 before the advent of Python 4. It's easy with Tox. We just add another environment to the env list. In this case, obviously, when we will run tox-shell, we will have a list of 2 environments instead of only 1. we can see that our test environment will probably remain the same. We don't want to change the talks track for our main line that is based on 2.7, but we can specialize the test-env defaults for the Python 3.4. In this case, talks will start and run at first the tests in the environment Py27. Then, when processing Py34, he will check, okay, I've got dependencies in test-env, but I have for this environment an override on dependencies. That's here. In this case, the original line will be replaced with the requirements-3.txt. So here we can specify the requirements for Python 3, while here we will have the standard and original requirements. Moreover, this command parameter, as it's not overridden in the 3.4 environment, will be run as specified before. That's plain, that's easy. So add your new environment and specify it with with a footer test-env stanza. Another nice thing that Tox can do, at least the newest version of Tox, is to generate compatibility matrices. If we have to test our environment with Python 2.7 and Python 3.4 and with pandas 0.17 and 0.18, we don't have to write down all 4 environments. But this brace expansion, this bash-like brace expansion, will generate 4 different environments. So Py27 PD17, Py27 PD18, and so on. There is a major changes in our test-env. As we are not using plain Py27 and Py334 tags, we have to redefine those flags, those labels, via the base Python parameter. So here we define Py27 and Py34 pointing to Python 2.7 and Python 3.4. Okay? So redefine those aliases. Finally, we have to define the dependency associated to the environment labeled as PD. So PD17 means pandas, requires pandas 0.17 branch, and PD18 requires pandas 0.18 branch. Okay, I added one more line here, and this is because I want to pin a specific version of NumPy, and I want that both those pandas version use this specific version of NumPy. This can have many usage. One of them is just because I've got a specific NumPy version in a wheel package and I need to test in a fast way. For example, I don't have connectivity, for example, or I want actually to pin the package to this version. In this way, I can enjoy wheel as explained before, and I've got a way to create in a very few time 4 virtual environments to test my software. Tox is not only virtual environments, but it is integrated with other software. In our description, in our project description, we don't want just to pin packages or dependencies. We want to specify a code style too. So when our Java friend starts developing, we want to enforce and teach him a set of code style rules. How can we do it? We can just specify a new environment named Flake8. Flake8 is a wrapper around various packages including PAP8 and PyFlake. It checks code statically and it verifies if our code is compliant with a set of Python standard rules. For example, there are even more unused or undefined variables, or even if it finds errors. The nice thing about Flake8 is that it checks the configuration inside Toxini. So I can put Flake8 configuration into Toxini, and Tox becomes even more a project descriptor, and I have less files around. In this case, I just run the Flake environment that has different dependencies and command execution parameters, and it states that my package has an error. This error code is the standard code error number, and it states that this local variable f841 unused is assigned but never used. As I told before, Flake8 can read configuration from Toxini. See here, put code style policy directly in Toxini. Here I need some comments so I can always remember which are the meanings of each error code. So I'm going to ignore those 2 errors. For example, I don't want Flake8 to complain about line too long or unused variable. I set anyway a maximum line length of 15. Okay, the code I wrote before, if I add those policies to Toxini, make the before execution successful. So as the only error was an unused variable, now tox tells Flake to ignore it, and then it's ignored. Flake 8 can do a lot of things. It integrates with setup tools that can even set git hooks. So when I execute a commit on Git, he will trigger the execution on Flake and checks if before committing all my code style policy are compliant or not. Tox doesn't support system dependencies, but we can use unlisted environment. For example, let's call it devenv. So as you can see here, we have just Python 2.7. In this unlisted environment, we blank the dependency line, add a command to whitelist, and then install a set of Fedora packages. This is quite readable, this is quick and maybe dirty, covers a wide variety of simple use cases. The main advantage is that here we are concentrating our information inside tox. Another approach involves Docker and Docker Compose, which actually can still be set inside the list of commands you can specify inside tox. But maybe you just, in that case, you just don't want to use the devenv approach. With Docker Compose, we have many advantages. We define and describe our whole infrastructure. We have better isolation, and well, to avoid to pay a great price for this isolation, the smart thing to do could be share the wheel cache with the base system. Okay, so well, for those of you that doesn't know Docker Compose, it's just a tool that lets you describe applications, multi-container application with a YAML file. Here we have defined two containers, one named Python6, another one Python7, based on different Docker image. But when those containers are started, they share with the host system the wheel directory and the current directory mapped to the code folder. In this case, Docker just run tox-e py26, and in the other case, tox27. In this case, it could be useful to put commands in the make file to avoid writing documentation about how to start every single test. So define test suites into a make file and write down some commands there. There is actually another approach that is using docs, that is docs, sort of docs wrapper to be used with Docker, and this project was born under the OpenStack umbrella. Jenkins. Jenkins is a continuous integration server written in Java. It supports Tox. It has a Tox plugin. And well, once you log in into Jenkins, you can create various continuous integration pipelines. So you create the one associated to your project here. Okay, and remember, build a multi-configuration project. Once you press OK, you have another page where you insert the source reference of your code, for example, if it is on GitHub or whatever it is, wherever it is, and then you can specify the details of your Tox configuration. Before doing this, you are required to install all the Python version you need on the Jenkins machine. Well, into the project configuration page, you can see a Tox frame, and well, here you can just check all the version you are interested in. Okay, remember, if you pick here PyPy, you should install PyPy previously on that machine. Okay, and well, here is how you can add further Tox or Python configuration. This is a Tox axis, Tox kind of run. Then you save your project and play on the icon close, on the play icon close to the project name. That's it. Now Jenkins will use Tox to run your builds. There is even a continuous integration as a service. Its name is Travis.io. Travis supports system dependencies, and Tox integrates with it via Tox Travis plugin. What you should do is create a Travis YML file into your GitHub repository, specify the Python version you want to use. You can even run scripts conditionally based on the Python version. You should install Tox Travis plugin, and then here you can just use your Tox implementation. Well, that's it. So, continuous integration requires reproducibility and isolation. While the project object model is an established Java standard to build reproducible builds, Tox can partially mimic this behavior using virtualenv, pip, setup tools, wheels, flake8, but there are even more plugins and tools that you can use from Tox. Tox integrates with Jenkins and Travis.io and can be used with Docker via custom script, custom test classes, Compose, or OpenStack docs. Okay, thank you very much for listening. I'm really happy that Python Italia community gave me the opportunity to be here even from my home, and well, I hope to hug you everybody as soon as possible, maybe at EuroPython in Bilbao. Thank you.